Okay, we're going to be looking at 12.3, which is measures of dispersion. So let's take a look at measures of dispersion. Measures of dispersion are used to describe the spread of your data items. So let's take a look at what we've learned in this section so far, 12.1, 12.2, 12.3. We learned that if we have a whole bunch of numbers, right, a whole list of numbers, right, what we can do with these numbers is turn it into a table, right? Let it be either a group frequency distribution, a frequency distribution table, or a grouped frequency distribution table. I'll abbreviate here. All right, we also learned that we can turn it into a stem and leaf plot. All right, we learned from this group frequency distribution table or frequency distribution table that we can make a histogram if we wanted to, all right? Or we can make a frequency polygon. All right, so these are some of the things that we've learned in 12.1, right? This really here summarizes 12.1, right? This is your summary of 12.1. What we saw in 12.2 was if we have, let's just say, a histogram, right? The numbers located towards the center are your measures of central tendency, right? Being your mean, your median, your mode, and your mid-range. All right. But this section is 12.3, right? And it's measures of dispersion, which once again is used to describe the spread of data items. Let's not forget that this histogram, right, is just a whole bunch of data, right? So we want to now take measures of dispersion into consideration. So measure of central tendency is the center. Let's take a look at maybe I liked the whole thing, right? Everything, all of the data items, the spread, right? Because once again, measures of dispersion describes the spread of the data items. That would be measures of dispersion. Your spread, in other words. So one is talking about the center and the other one is about the spread. All right, so that's what 12.3 is all about, measures of dispersion. So a little different from 12.2. So we have two measures of dispersion. One of them is the range. And then the other one is your standard deviation. So let's talk about the range. The range is really easy, right? The range is found by subtracting the highest and lowest data value. Right, so once again, range equals your highest minus the lowest. All right, so nice and easy to find the range. Example. Find the range. I give you 4 to 11 and 7. All right, we just find the highest data value and the lowest data value and subtract them. Show our highest is 11, lowest is 2. Our answer here is 9. And let's call this example A. How about example B? Maybe I give you a histogram. Right, I give you 1, 2, 3, 4, 2, 3, about 4 and 5. Okay. Once again, let's not forget that the x values refers to our data, and the y values refers to the frequency, and the range is the subtracting highest and lowest data values. So your range is the highest is 4, right? That's the highest, minus 1 is the lowest. This answer is 3. All right, so the range is very nice and easy. Now we're going to spend some time talking about standard deviation. The standard deviation is very important in statistics. Right, this is a measure that's dependent on all of the data items. All right, so it's dependent on all the data items. And in order to compute it, right, in order to find the standard deviation, what we need to do first is find how much each data value deviates from the mean. So what we first have to do then is find the mean, which we can call x bar. All right. Then second, we can subtract the mean from each data item, right? X minus x bar. So let's start there, right, as our first example. All right, what we want to do is we want to find the deviations from the mean for the following data items. We have 69, 68, 65, 64, and 64. All right, so this is how we're going to start here. We want to find the deviations from the mean for the following data items. So first, let's find the mean. We did this in your last homework assignment, right? So we add all the numbers, 69 plus 68 plus 65 plus 64. And we divide it by the amount of items we have. We have what? 1, 2, 3, 4, 5, 6. We add all the top numbers up. Looks like we get 330 over 6. And then we divide. So we get this mean to be 66. All right. Now what we want to do is find our deviations. Right? We want to find our deviations. And your homework may show it where it has a table, right? And one of the rows reads X bar. The other row reads X minus X bar. And I'm sorry, it doesn't read X bar. This just here reads X. Right, and it would have your data items, right? 69. Sorry, let me go ahead and charge this here real quickly. I didn't realize that. Oh, it's my pen. So we have 69, 68, 65, 64, and 64. All right, so what we see here is the first row refers to the data items. The next row would be your X minus your X bar, or your mean. And we found the mean to be 66. So we're just going to subtract each data item. Each data item will be subtracted from 66. Right? So this would be 66 minus 69. All right, which gives us 3. 68 minus, I'm sorry, let me fix that. All right, should be the other way around. Right, your X is 69 minus your mean is 66. Okay, then 68 minus 66, which gives us 2. 65 minus 66, which gives us a negative 1. Your 64 minus 66, which gives us a negative 2. Then again, your 64 minus 66, which equals negative 2. Right, remember this is called deviation. Right, so finding the deviation is really nice. You first, once again, find the mean, and then second, you can find your deviations. And third, you just want to check your work. Very important. Here, the deviations must sum to equal 0. So if we add 3 plus 2 plus negative 1 plus negative 2 plus negative 2, we see that this does equal 0. So our work is in fact correct. So now let's go ahead and next video we'll talk about finding standard deviation.